Hello and welcome to this video, and today we're going to be taking a look at extended voltage dividers like the one we have here, and that is just a voltage divider that's got more than two resistors, and we're going to use our knowledge that we already have about voltage dividers with two resistors, and we're going to define ourselves a function in Python that is going to give us a voltage at each branch in this circuit. So here we have a circuit diagram of a voltage divider, and we've got 5 different resistors and a supply voltage of 5 volts. So now what we want to be able to do is to look at each of these branches and be able to find out what we'd expect the voltage at that branch to be. So the advantage of using a Python script or function to do this is that the function that we create is going to be very versatile. And we could use the same function for a voltage divider with 20 resistors or 200 resistors, and we'll be able to easily change how it works and all the different parameters, such as the input voltage and the resistances of the individual resistors. So just looking at this, we need to come up with a super systematic approach to this problem and find what is essentially the general solution for voltage dividers. So let's think about our typical voltage divider circuit formula with two resistors, which is R1 over R1 plus R2 times the supply voltage. So if we wanted to generalize this with the one we have here, if we are picking a branch, say this second one here, we can look at these two resistors in series and just treat that as one big resistor. So that would be our first resistor. And these other three are going to be the second resistor, because resistors in series just add up. Now all of a sudden we have simplified this problem so that it is back to our two resistor voltage divider. Here we are in Python, and you can see we've got our list of resistances here, and we can print the length of this by doing print and then len resistances list, and you can see we've got a list of 20 resistances. So now we can begin to define our function. So we'll write def, and we'll give it a name. I'm going to call it voltage divider. And then we need to decide what parameters we need to pass into our function. So we're going to need the function to be told the resistances of the resistors in the voltage divider, which branch we want to see the voltage of, and then we're also going to have to know the supply voltage. So if we think about our voltage divider equation, the thing at the bottom of the brackets is the total resistance from the supply to ground. So we can just say R total is equal to the sum of resistances. The other thing we need is the resistance of the resistor we're trying to measure the voltage across. So when we're measuring the voltage of one of our branches, what we're really measuring is the voltage between that branch and ground, because it's a potential difference. So you need to measure between two places. So the resistor we're going to be measuring is going to be between our branch and all the ones after it towards ground. So we can say sum of resistances, and that is going to be from branch to the end, slicing it like that. Now all we have to do is find the voltage at that branch, and what we'll do is use our equation. So we'll do R1 divided by R total, then multiply that by the supply voltage. So then all we need to do is return voltage. So we'll run that to define it. And now to test that that's working, we can create a for loop. So for I in range, we'll go from 1 to 20, but you have to do it one higher for the last index because it's non-inclusive. So it will only go up to 20 here. And we're just going to print an F string. So we'll say the branch, and then we'll print what number of branch it is, add a colon, and then we'll call our function. So we'll say voltage divider, call resistances list, branch, which is just going to be I, and the voltage in, which we saw in our picture, was 5 volts. So now if we run that, we can see that we've got all of our different voltages here at the different branches. And as we'd expect from the last branch, that is essentially just testing ground. So of course it's going to be 0 volts. And so that is our code functioning correctly. So I hope you found this useful, and thank you for watching this video.